It's time for your monthly dose of AI news, and this one's wild. We've got humanoid robots that can run and think faster than us, AI cops already on the streets in China, and self-teaching agents outsmarting even OpenAI. DeepMind managed to break its own AI with a single sentence. Microsoft accidentally built its most efficient model yet. And Meta's massive 2 trillion parameter Llama is finally here. Meanwhile, China's dropping AI agents that move 8 times faster than DeepSeek and releasing video generators that look more real than reality itself. So let's get into it. Westwood just unveiled a humanoid robot that can run at 10 kilometers per hour, balance on rough terrain, and react 1,000 times per second. Meanwhile, 1X is showing off a robot that loads dishwashers, picks up leaves, and places pillows, completely on its own. These aren't just flashy demos. This is the next phase of robotics, and it's moving fast. Let's start with Westwood Robotics' Themis V2. This thing stands around 5 feet 3 inches tall, so picture a life-size robot that's pretty close to your height if you're of average stature. One major headline feature is its 40 degrees of freedom. That just means it can bend and twist in 40 different ways. The arms have 6 degrees of freedom each, and the hands, or end effectors, bump that number up by 7 for finer movements. It's a second-generation model, so Westwood clearly built upon their first iteration to make it more fluid and capable. One reason it's become so fluid is that they upgraded the arms, giving them better articulation, so the robot can handle tasks that require a good amount of dexterity, like carefully picking up objects. Now, under the hood, Themis V2 features something called BEAR actuators, which stands for Back-Drivable Electromechanical Actuator for Robotics. The back-drivable part means it can smoothly move a joint in both directions without that jerky mechanical motion you sometimes see in older robots. It makes the movements more lifelike and, importantly, safer when operating around humans or delicate objects. If the robot accidentally bumps you, it doesn't feel like getting whacked by a car door. It's more controlled, with enough awareness to sense resistance and adjust accordingly. Powering all that brainy stuff is the robot's AI computing capability, which apparently cranks out around 200 pops. That's tera operations per second. In plainer language, that's a ton of computing horsepower. Because of this serious processing ability, the robot can run advanced machine learning algorithms right on board, letting it respond more quickly to changes in its environment. Speaking of changes in the environment, it also has a neat little gadget for balance and motion tracking, the 3DM CB7 AHRS sensor from MicroStrain by HBK. That sensor basically makes sure the robot knows exactly how it's tilting or turning up to 1,000 times every second. Picture it almost like an inner ear on steroids, giving the robot a constant stream of orientation data so it can handle uneven surfaces, stairs, or any random obstacle that might pop up. Combine that with the Robot Operating System, or ROS, and you get a super flexible software framework that allows developers to teach the robot new skills or tweak how it behaves in specific scenarios. Westwood claims their new humanoid can walk about as fast as a typical human, and they've even clocked it running up to 10 kilometers per hour, which is roughly 6.2 miles per hour. So if you decide to go for a jog, this robot could technically keep pace. They've been showing off some of its more extreme moves, like running, maybe even trying out a little parkour or jumping over low obstacles. The big takeaway is that they're designing this machine to handle real-world situations, not just theoretical test labs. If it's truly stable when the floor gets a bit rough or when it has to pivot quickly, that's a huge step forward in humanoid robotics. While Westwood focuses on a super capable humanoid that looks poised for tasks anywhere from industrial environments to more personal applications, there's also 1X's robot called Neo, which is being aimed straight at your home. The vice president of AI at 1X has been posting online about how Neo is picking up leaves, loading dishwashers, and even rearranging pillows on a couch. Now, maybe that sounds mundane. Oh, it's just picking up leaves, big deal. But it's actually pretty significant to see a robot autonomously spot leaves, scoop them up, and drop them into a bag without a remote operator. Autonomy is the magic word, folks. It's easy to show off a slick video of a robot moving around if someone behind the scenes is controlling it, but 1X claims that Neo is actually doing these tasks all on its own, making decisions in real time based on what it sees, how it's positioned, and where objects are located. One of their demo videos shows Neo working on what is arguably one of the most annoying chores in any household: loading the dishwasher. It picks up a cup, transfers it from one hand to the other, aligns it with the dishwasher rack, and then places it in there. It might not sound super flashy, but think about how many tiny calculations go into that. Figuring out the shape of the cup, ensuring it's not too slippery, orienting it so it fits in the right slot, and making sure the robot itself stays balanced while bending over. In the video, the dishwasher was already open, and the cup was just sitting there. So it wasn't exactly reinventing the wheel, but it's a perfect example of the baby steps, or should I say robot steps, needed to tackle the chaos of a home environment. Another scenario they showcased was the robot walking over to a couch, picking up a cushion, and placing it down neatly. It's pretty interesting to watch it keep its balance while leaning forward with the cushion, especially given that the cushion itself is soft and somewhat unwieldy. Anyone who's tried to get a toddler to place a pillow in a corner without toppling over might appreciate how many balancing corrections are needed. The 1X team emphasizes that these examples, while relatively straightforward, illustrate the complexity of real-life tasks. Homes are messy and unpredictable. You've got rugs, pets, children running around, and furniture that's never exactly where you left it. To perform tasks effectively, a robot has to handle all those variables without getting jammed up when something changes unexpectedly. According to the 1X vice president of AI, everything you see in their demos is driven by data and a comprehensive network that controls full body motions from the lower body to the arms and the spine joints. And they're using reinforcement learning, AR, for the lower body and merging that with the rest of the system to achieve graceful movements. He even draws parallels to the idea that a robust consumer solution, which in this case means for everyday household tasks, can ultimately generate extremely valuable data for training more advanced general-purpose intelligence. It's the same kind of argument that Tesla has used for its self-driving program. The more data you collect on ordinary roads with average users, the better your AI becomes at handling all those weird corner cases. If you try to confine your robot or your AI to some very specialized and controlled space, you might not get enough diverse data to level up the intelligence as quickly. This is why 1X is specifically gunning for the home environment first. They're calling it the final boss of robotics because it's an absolutely unstructured environment full of a never-ending list of tasks. If a company tries to tackle robotics in smaller, narrower contexts like a warehouse where everything's neatly arranged and predictable, that might sound easier at first, but ironically, you can end up in a situation where you're not exposing your AI to enough variety. In a home, one moment the robot might need to pick up a piece of laundry and the next it has to deal with the pet dog wandering into the room. Or it might have to open a jar of pasta sauce, then realize that the jar's lid is stuck and needs extra force. Those little scenarios provide an avalanche of new data, training the AI to handle unplanned events. The argument is that a highly unstructured environment could speed up the development of a general intelligence by constantly challenging the robot with fresh tasks. The folks at 1X are being real about where things stand. They're not claiming their robot Neo can jump from loading the dishwasher to doing laundry without hiccups. It's not there yet. But the idea is to let the robot keep trying, make mistakes, and learn from them, just like how AI models improved by collecting tons of data over time. They even compare it to self-driving structured environments like highways don't give you enough challenges to grow. Homes, on the other hand, are chaotic, which actually helps the robot get smarter faster. So yeah, between Westwood's Themis V2 packed with serious hardware, sensors, and AI muscle, and Neo, which is out here doing leaf pickup and placing couch cushions on its own, we're seeing major steps toward robots that can handle real life. It's still early, but these are the kind of breakthroughs that could one day give us general-purpose robots that do way more than just vacuum. Thailand's Songkran Festival went next level when the Royal Thai Police rolled out AI Police Cyborg 1.0, a RoboCOP-style bot with 360-degree cameras and real-time facial recognition AI. Over in California labs, Disney Research introduced a humanoid robot that mirrors your shyness or excitement on the spot. And in Beijing, 21 bipedal bots lined up against 10,000 humans in a half marathon, finishing more than an hour behind. Meanwhile, Vegas is gearing up for Autonomous, the world's first fully AI-operated hotel, and Ocado's robotic arms are already packing over 30 million groceries a year using computer vision, reinforcement learning, and diffusion-based generative AI. So let's talk about it. All right, let's kick things off in central Thailand, where the Songkran Festival turns the city into a massive water-throwing extravaganza for the Thai New Year. On April 17, 2025, the Royal Thai Police unveiled Pol Kol Nakhon Pathom Plod Pai, which literally means Nakhon Pathom is safe. But it's not a person, it's a RoboCOP-style AI police Cyborg 1.0. Picture a towering uniformed robot officer standing guard on Tansen Road in the Muang district of Nakhon Pathom province, decked out in the same dark blue garb you'd see on any local cop. This thing is stationary for now, but it's anything but passive. It's fitted with smart 360-degree cameras that don't just roll tape, they feed live footage into an AI system. That system pulls in video from nearby CCTV and even drone surveillance, then runs it all through onboard video analytics chips. Everything loops back to the province's command and control center, so if anything sketchy happens, human officers get real-time alerts. And these aren't basic motion detectors. We're talking facial recognition that can flag individuals on a blacklist, suspect tracking that follows you through the crowd, and advanced searches based on, get this, clothing color, body type, even gender. It can also spot blades, wooden sticks, and things that look like weapons, but it smartly ignores water guns because, well, that's the whole point of Songkran, right? Last but not least, it monitors behavior for anything violent or disruptive. Fighting, shoving, that sort of thing. This project is a collaboration between Provincial Police Region 7, Nakhon Pathom Provincial Police, and the Nakhon Pathom Municipality. According to the RTP's Facebook post, they're hoping this marks a new era of tech-enhanced public safety at big events. And it's not alone. Back in March, Shenzhen, China rolled out humanoid patrol robots that can interact with pedestrians and follow voice commands. So it looks like Asia is in a full-blown AI policing arms race. Now, let's switch to Disney research. On April 13, 2025, they introduced a humanoid robot that reads and reflects human feelings in real time. Imagine a little Wall-E-looking character, but with a face and body language that shows shyness, excitement, friendliness, all in real time. And real time is the key here. As you interact, it picks up your cues and mirrors your emotion almost instantly. Under the hood, Disney's team uses a two-part AI model, a diffusion process for smooth, continuous motions, think waving or leaning in, and a classifier for discrete actions like saying hello or gesturing a thumbs up. During training, a human operator remotely guided the robot's responses using social intuition. If someone approaches shyly, the operator makes the robot shy back. Those guided interactions get recorded, fed into the AI, and boom, you've got an autonomous machine that can emulate natural gestures on its own. But perhaps the real star is Newton, an open-source physics engine built by Disney Research with NVIDIA and Google DeepMind. Newton addresses the sim-to-real gap by simulating ultra-realistic virtual environments where robots learn everything from handling soft objects to balancing on uneven ground before entering the real world. It's got differentiable physics so the robot can optimize moves by simulating outcomes. It's extensible so you can teach robots to interact with food, fabric, whatever. And it runs on NVIDIA's Warp Tech, making simulations up to 100 times faster than the old school. Disney's already using Newton to supercharge its robotic characters, like the Star Wars-inspired BDX droids they showed at NVIDIA's GTC keynote earlier this year. Those bots not only act in theme park performances, but can backflip, play out scenes, you name it. Kyle Laughlin, SVP of Walt Disney Imagineering R&D, says they're building a new generation of robotic storytellers, machines that don't just assist, but actually connect with people, make them laugh, maybe even tear up a little. And yeah, they can pull off a perfect side flip acrobatics move that would put some gymnasts to shame. Next, we're in Beijing on April 19, 2025 for the world's first human vs. humanoid half marathon. So a 21-kilometer race about 13 miles, winding through the E-Town district. There were 10,000 human runners and 21 bipedal robots from companies like DroidVP, Notix Robotics, and the Beijing Innovation Center of Human Robotics. Heights ranged from under 1.2 meters to nearly 1.8 meters. Some even sported boxing gloves and headbands for style points. Every so often, humans hit a water station. The robots got tuned up at aid stations with fresh batteries and technical tweaks from their engineers. And let's just say the robots didn't stand much of a chance. The winner among humans clocked in at 1 hour, 11 minutes, 7 seconds. The fastest robot, Tiangong Ultra, rolled through the finish line in 2 hours and 40 minutes, over an hour and a half behind. Others fell over right at the start. One bot collapsed and lay motionless before an engineer picked it up. Another slammed into a barrier, taking its handler down with it. Organizers made it clear it was more of a tech demo than a competition. They never expected the robots to win. Alan Fern, a robotics professor at Oregon State University, pointed out that while these demos highlight feats of agility, running, dancing, they don't really speak to practical intelligence or useful work. But China's government is pouring investments into AI and robotics as a way to drive economic growth and catch up with the US. You know, creating new engines of industry and all that. Still, not everyone's down on the spectacle. Tang Zhen, CTO of Tiangong's lab, says the focus is shifting from flashy stunts to real-world applications. Industrial tasks, factory work, even household chores. And He Shu, a local AI engineer watching from the sidelines, said, "I feel I'm witnessing the evolution of robots and AI." So while the bots may not break any speed records, the event makes it obvious bipedal robots are evolving, and we're only at the beginning. Okay, let's switch gears now to Sin City, Las Vegas, where something wild is about to open. Autonomous, the world's first hotel fully powered by AI. Written up on April 19, 2025 by Bibiana Palacios, this place will boast 550 rooms, each a generous 856 square feet. Every suite is tricked out with artificial intelligence systems that learn your preferences, like how you take your morning coffee, and even generate a personalized avatar during digital check-in. There are two patented AI engines at work here. First is Phiro, the reservation engine that uses optimization algorithms to allocate rooms and let you customize your stay with different setups, views, gaming consoles, whatever floats your boat. Then there's KEE, which acts as your digital room key and virtual assistant. No front desk, no receptionist, just tap your phone or talk to the room, and KEE handles everything from unlocking the door to ordering extra towel. Don't worry if you miss the human touch, Autonomous has you covered. Guests who want old-school service can opt out of some tech features and get a more traditional, face-to-face concierge experience. The hotel is slated to open in May 2025, with base rates starting around $300 per night. And if you're wondering how AI like this even works, Autonomous breaks it down in plain English. AI systems absorb tons of data, images, text, voice, then use algorithms to spot patterns, make decisions, and improve over time. They describe 4 development stages: reactive AI, which has no memory; limited memory AI, which learns from recent data; theory of mind AI, still in development, that could understand human beliefs and emotions; and self-aware AI, purely theoretical at this point. So while Autonomous is pushing the envelope in hospitality, they're also showing you a little roadmap of how AI evolves. Last but definitely not least, let's look at how AI is transforming grocery supply chains. And spoiler alert, it's not in a fancy hotel or on a street corner, it's in the back room of your favorite online supermarket. On April 15th, 2025, Libby Hargraves highlighted Ocado's on-grid robotic pick system, OGR for short, which blends computer vision, machine learning, and smart sensors into robotic arms that pick and pack groceries. In 2024 alone, OGR picked over 30 million individual items in Ocado's warehouses. That's not a typo, 30 million. And it's only a small number of arms too, delivering huge productivity gains. These arms aren't just following pre-programmed motions, they observe human demonstrators, use reinforcement learning to refine their technique based on success or failure, and employ behavior cloning to mimic the way humans handle delicate strawberries or awkward-shaped jars. Each arm is bristling with sensors, cameras to identify the product and its packaging, pressure sensors to gauge grip strength so it won't crush an egg carton, and motion sensors for smooth, precise movement. And because these robots share what they learn, if one figures out how to pick a tricky pear without bruising it, that knowledge propagates across the fleet. Now, Ocado is also dipping into generative AI with diffusion models. Traditionally, generative models are for art and text, but here they're used to help robots generalize skills to new items they haven't seen before. In practical terms, that means faster onboarding of new products and even finer levels of efficiency. All right, this one's packed. China just put a humanoid robot on police patrol. Xpeng's android wowed crowds at Auto Shanghai with freakishly human-like moves, and Abacus just gave its Deep agent a serious upgrade with a new Pro tier that lets you build entire apps and deploy websites in one go. Meanwhile, Tesla's scaling up Optimus production, Chery's using AI robots as sales staff that talk, walk, and even gesture like people. A 20-foot AI robot is about to take over construction sites. Meta launched an AI assistant that follows you across all devices. And Huawei's latest chip might finally be a real threat to NVIDIA. Let's get into it. Let's start on the streets of Shenzhen, where Engine AI's PM01 just became China's first humanoid police sidekick. The little guy stands 1.38 meters tall, weighs 40 kilograms, and wears the same high-visibility vest as its human partners. What makes PM01 pop is agility. A 320-degree waist rotation lets it scan crowds without shuffling its feet, and last month it pulled off a fully landed front flip that went viral on Chinese social media. Under the plastic shell sit industrial-grade actuators, a vision stack that can identify faces and license plates, plus microphones tuned for voice commands in Mandarin and Cantonese. Engine AI is selling business and education versions for 88,000 yuan, about $12,000. So surprisingly, it's cheaper than Unitree's sportier G1. For now, the PM01 is greeting tourists and keeping an eye on lost kids, but local police say it can also forward anything suspicious straight to the command center in real time. The Patrol project is part of a broader Chinese push to sprinkle robots into public safety jobs. Late last year, officials tested the RTG, a spherical bot that cruises on land or water at 35 kilometers an hour and can survive a 4-ton impact. Deep Robotics, meanwhile, has its wheel-legged Lynx scrambling upstairs with thermal cameras to spot fires before firefighters even suit up. PM01 is the first to bring a truly humanoid form factor to that mix, and at 12 grand a unit, it's budget-friendly enough that a city could field an entire squad without breaking the treasury. While the pint-sized RoboCOP keeps things civil down south, Auto Shanghai 2025 turned into a full-blown robot fashion show up north. The undisputed star was Xpeng's humanoid Iron, a 5'8", 154-pound android designed to blur the line between self-driving cars and service robots. Engineers stuffed 60 joints into its frame for a total of 200 degrees of freedom. The hands alone have 22, so Iron can thread a needle or tap a touchscreen without that stiff marionette look most bots still suffer from. All that motion is driven by Xpeng's custom Turing AI chip, capable of 3,000 trillion operations per second, which is downright server class. Even cooler, Iron runs the exact same cockpit AI that guides Xpeng's electric vehicles, so your future sedan and your future housekeeper could literally share a brain. Xpeng calls this its AI tech tree, a roadmap where EVs, humanoids, and even flying taxis operate on a common software spine. In the demo, Iron Fist bumped audience members, answered questions in natural Mandarin, and lifted a delicate porcelain cup without cracking it. Subtle, but a big deal in the world of robotic manipulation. Timing for super capable software agents could not be better because the humanoid arms race is heating up fast. Over on X, Elon Musk posted a new clip of Tesla's Optimus walking with a gait that finally looks human instead of, "I just stepped on a Lego." Musk says Gigafactory Texas will crank out 10,000 Optimus units by December 25 and predicts a long-term future where robots outnumber people, maybe 2 to 1, maybe 10 to 1. Each Optimus borrows Tesla's EV DNA, battery modules from Model Y, drive motors scaled down from Plaid, and the same FSD computer for perception. The idea is simple. If you can mass-produce cars, you can mass-produce androids. Not to be outdone, fellow Chinese carmaker Chery is already staffing its Malaysian flagship showrooms with its own bot, AMOGA, that's artificial intelligence with multi-objective genetic algorithm, if you're wondering. AMOGA wears a silicone face and long blonde hair to soften the uncanny valley vibe, but under the cosplay it packs 41 degrees of freedom, including 12 per hand, and hustles around at a full meter per second. A 5-way sensor matrix enables centimeter-level obstacle avoidance, and thanks to DeepSeek models, the robot chats in 10 languages, pitching car features without the high-pressure sales tactics humans sometimes bring. Chery calls it a human-like motion library, and judging from the videos, the arm gestures really do look natural. Now, shift your gaze from the showroom floor to the construction site, because California-based RIC Robotics thinks bigger. Literally, its upcoming Zyrex robot will stand 20 feet tall, towering over any foreman, with beefy arms capable of welding, carpentry, and large-format 3D concrete printing. The prototype is scheduled for early 2026, and RIC claims it will address two huge pain points. The US faces a shortfall of roughly 439,000 skilled construction workers next year, and the industry logged 1,075 fatal injuries in 2023, the most of any sector. Zyrex uses LiDAR and vision language action models to compare real-time sensor data with BIM blueprints, minimizing mistakes while keeping humans out of the danger zone. Price? Under $1 million to buy or under $20,000 a month to lease, roughly the same as hiring a small crew. All of these robots still need serious compute, and Meta thinks the smartest place to deploy that compute is in your pocket. The company just launched a standalone Meta AI app built on Llama 4. Open it and you'll see a Discover feed, a kind of prompt TikTok, where users share clever use cases you can remix, flip on voice mode, and you get a glimpse of full duplex speech tech. The assistant speaks and listens at the same time, so the conversation flows more like a phone call than a series of walkie-talkie bursts. For now, that demo is limited to the US, Canada, Australia, and New Zealand, but Meta plans to roll it out wider. The app ties into Ray-Ban Meta glasses and the Meta AI website, meaning you can start asking a question on your glasses, continue on your phone, and finish at your desk. It also pilots a rich document editor that can generate PDF reports full of text and image sections or analyze documents you import. And yes, it remembers personal details, like that you're into Japanese city pop, so answers feel less like a search engine and more like an informed friend. Speaking of raw compute, Huawei just fired a pretty loud shot across NVIDIA's bow. Word out of Shenzhen is that its next-gen Ascend 910D accelerator, think of it as the fourth iteration after the 910, 910B, and 910C, is already on the lab benches, and engineering samples should roll out in late May. The goal, according to people briefed on the silicone, is straightforward. Match or beat NVIDIA's H100 on the one metric everyone cares about: training throughput for giant language models. For context, an H100 tops out around 4.9 terabytes per second of memory bandwidth and roughly 1 petaflop of FP16 compute, which is why the big cloud providers hoard them. Huawei's current 910C hits about 800 petaflops INT8, or around 400 petaflops FP16, with a power envelope that slots into standard 700-watt data center racks. And the company claims the 910D will push those numbers even higher while tightening energy efficiency. If that happens, the impact inside China will be sizable. NVIDIA's H100 and the new B200 are both on Washington's restricted list, a policy that began in 2022 when the US classified top-end AI GPUs as dual-use tech. That cutoff left Chinese LLM teams scrambling for supply, paying gray market premiums, or downclocking to older A100 stock. The homegrown 910D that can drop into existing PCIe or Huawei's Kunpeng servers would instantly relieve that bottleneck and keep local model training onshore. There's also a bigger backstory. Huawei has spent 6 years on the US entity list, yet it keeps finding ways around roadblocks. In 2023, it stunned analysts by shipping the Mate 60 Pro phone, powered by a fully domestic 7nm Kirin chip fabbed at SMIC. The Ascend line follows the same playbook. Lean on China's bleeding-edge lithography, stack massive on-chip SRAM to offset slightly older process nodes, and optimize the software stack through its CAN compiler so PyTorch and MindSpore can squeeze every tera operation. Shipments of the 910C are already slated to hit Chinese hyperscalers next month, giving developers a stepping stone until the 910D ramps production. In short, Huawei isn't just catching up to NVIDIA, it's positioning itself as the safety valve for China's entire AI ecosystem. See the pattern? Street-level patrol bots like PM01 scoop up data, Huawei's Ascend 910D choose it, and agents such as Deep Agent turn the output into dashboards you can actually use. Out on the frontier, Iron, Amoga, Optimus, and the towering Zyrex keep stretching the definition of robot, while Meta's new assistant follows you from phone to desktop to smart glasses, always in sync. So when you glimpse a vest-clad bot waving at tourists or read about a 6-meter mech printing a supermarket, remember you got the timeline here first. And if Deep Agent pings Slack at 3 a.m. to say it shipped your project, relax. That's just tomorrow showing up early. So ByteDance just dropped UTARS 1.5, and the short version is this. It's a vision language agent that treats your screen like one big image. It can read, reason about, and then manipulate directly. Instead of juggling DOM trees, calling external tools, or stuffing the prompt with handcrafted instructions, the model ingests a screenshot, figures out the layout and the task from plain language, and then acts natively as if a real user were at the controls. That shift, folding perception, planning, and low-level actions into one neural backbone, changes the game for GUI automation, game agents, and any workflow that lives inside a graphical interface. It's faster, it's more resilient when the UI changes, and in head-to-head benchmarks, it's already edging out GPT-4-based setups and Claude on everything from Windows desktops to Android apps to web navigation. So they started with the original UTARS a few months back, but version 1.5 is the beefed-up sequel. Under the hood, it's still Qwen 2VL at heart, but they scaled it 3 ways. A lightweight 2 billion parameter model, a mid-range 7 billion, and a chunky 72 billion variant that got an extra round of direct preference optimization. Across 50 billion tokens of training, screenshots, element metadata, GUI tutorials, and bootstrapped action traces, the team taught the model to see, reason, and click in a single pass. The first big upgrade is how it looks at a screen. They scraped websites, Windows apps, Android UIs, even CAD and Office software, yanked the bounding boxes, the labels, the colors, the tiny 10 by 10 pixel icons, everything, and synthesized 5 flavors of perception data. Element descriptions tell the model, hey, that little blue square with the floppy disk icon is a save button. Dense captions stitch all the elements into a global paragraph, so the model gets layout context. State transition captions teach it to notice subtle changes like the difference between a button-down frame and a hover frame. There's a giant heap of screenshot Q&A so it can answer short questions such as, where's the new tab button? And they sprinkled in set of mark prompting, basically drawing colored markers on elements, so the agent can ground language tokens to specific pixels. Now, seeing is cute, but acting matters. ByteDance defined a unified action space, shared primitives like click XY, drag, scroll, type, wait, plus desktop specials like hotkey or right-click, and mobile-only press back or long press. On top of that, you get 2 meta actions, finished when the job's done, and call user when it's stuck behind a login wall. They collected millions of multi-step traces, open source stuff like Mind2Web, AITW, Android Control, plus their own hand-recorded sessions, and normalized every step into that action template. Average trace length? Around 15 steps in their in-house set, so the model learns long horizon control, not just single taps. Reasoning is where version 1.5 shines. The paper splits human-style thinking into System 1 and System 2. System 1 is the fast, intuitive, just click the button vibe. System 2 is the deliberate, chain of thought, break the task down vibe. Task decomposition, milestone recognition, trial and error loops, reflection when things go sideways. They harvested 6 million gangs GUI tutorials off the web, about 500 tokens each, 3 pictures on average. Ran them through a fast text filter, a big LLM cleanup, and used that as a reasoning primer. Then, for every action trace they already had, they retrofitted a thought, first with Act3 prompting, then with a clever bootstrapping trick where the model samples multiple thought action pairs and only keeps the pair that actually works. Those thoughts sit in context, so before every click, you literally get the model's inner monologue, like, okay, search field detected, type the username next. Because agents crash in real life, they taught the model to learn from mistakes. They spun up hundreds of virtual PCs, let an early checkpoint roam free, captured the messy traces, filtered the junk with rules and VLM scoring, and sent human annotators to label 2 critical steps, the wrong move and the correct fix. That gave them paired samples for direct preference optimization. DPO's job is simple: reward the fix, penalize the blunder, keep the policy close to the stable SFT baseline. After a few bootstrapping rounds, they saw the 72 billion surrender model jump from 17-ish to over 24 points on OS World's 50-step budget. All right, numbers, because everybody asks for the scoreboard. In the synthetic desktop sandbox OS world, UTAR's 1.5 nails a 42.5% success rate with just 100 steps, beating OpenAI's Operator at 36.4 and Claude 3.7 at 28. Windows Agent Arena, a tougher 50-step Windows challenge, shows 42.1% for TARS versus the old 29.8 baseline. On Android World, the 7B model pulls 64.2%, topping the previous 59.5%. When it comes to naked grounding, pointing to a widget, ScreenSpot V2 clocks UI TARS 1.5 at 94.2% accuracy, Operator at 87.9%, Claude 87.6%. The new ScreenSpot Pro, which uses high-res professional apps, is where the gap gets crazy: 61.6% for TARS, only 23.4% for Operator, 27.7% for Claude. Gaming? They fed the model 14 Pokey mini-games, 2048 Infinity Loop, Snake Solver, and so on, and the agent clears every single one, literally 100% across the board, while Operator and Claude flop on half the titles. Minecraft's MineRL benchmark is more humbling, but still, with the Think Then Act mode turned on, TARS 1.5 gets 42% average success on 200 mining tasks, 31% on the 100 mob killing tasks. The older VPT or Dreamer V3 agents barely cracked 1% on those same goals. To prove it's not just cherry-picked demos, they published the full benchmark table in the blog. Web Voyager browsing tasks? 84.8% for TARS versus 87% for CUA, but marginal. Mine-to-web online tasks at 75.8% against 71% for OpenAI's CUA. Notice the pattern. On web browsing, Operator stays competitive, but once you leave HTML land, and especially once you hit desktop or mobile, UI TARS pulls ahead. Scale tests are neat too. Take the original 72B DPO checkpoint on OS World, 24.6 points. The mid-size 7B version with the same training setup reaches 42.5 points because that one is optimized for desktop tasks instead of games. The tiny 7B Lite release clocks 27.5 on SpawnSpot Pro, 38.1% for the earlier 72B DPO, 49.6 for the new 7B, 61.6 for the full 1.5. So bigger isn't always better. Targeted data and the thought engine matter more than raw parameters for grounding. Deployment is refreshingly open. They pushed the 7B checkpoint to Hugging Face under Apache 2.0 at ByteDance seed/UTARS 1.57B. The full 72B weights are under early research access. You basically email tars@bytedance.com, tell them your project, and cross your finger. The GitHub repo, github.com/bytedance/utars, has training scripts, the unified action schema, the screen capture toolchain, even replay data, so you can reproduce their metrics. If you just want to play, there's also UTARS Desktop, a Windows X that lets you type a natural language prompt and watch the agent drive your PC. Think of an open source operator, but without the GPT-4 subscription. From a research meta angle, the paper goes full history lesson. It tracks GE agents from old school rule-based RPA to modular LLM frameworks like AutoGPT to these new end-to-end native models. Rule-based stuff is brittle, frameworks are prompt engineering heavy and fall apart when a UI shifts. But native agents, being data-driven, retrain on fresh traces and just adapt. That's why ByteDance keeps banging on the 4 core capabilities. Perception, know what's on the screen. Action, hit the right coordinates. Cross, debit. Reasoning, swap between System 1 and System 2 as needed. And memory, store short-term context in the prompt, long-term lessons in the weights. Stick those in one model and you get something that can reboot itself when Windows throws a pop-up. Training followed 3 phases. Phase 1, straight continual pre-training on everything, around 50 billion tokens, flat learning rate. Phase 2, an annealing stage, where they only keep high-quality perception, grounding, action, and reflection pairs, so the loss focuses on difficult examples. They call that checkpoint UTARS SFT. Phase 3, DPO on the reflection pairs, which bakes in the preference for fixed actions. That's Utah's DPO, the model that hit 24.6 on OS World. On offline benchmarks, things are already strong. In multimodal Mind2 Web, the 72B model posts 74.7% element accuracy and a 92.5 operation phone. Android control low-level tasks, 89.9% grounding, and a 91.3 success rate. GUI Odyssey's cross-app mobile navigation hits over 88% success, which beats OS Atlas 7B by about 26 points. Yet the more impressive bit is how System 2 reasoning starts to shine the moment you give the model more than one sample. In best of one sampling, the no-thought version sometimes edges ahead because the deliberate chain of thought can hallucinate. But at best of 16, the thought-based policy overtakes, and by best of 64, it's way better, because the extra sampling lets the model explore multiple reasoning paths and keep the best one. Out-of-domain deliberate reasoning wins straight away. On Android World, which the model never saw during training, the thought-enabled 72B cleans up at 46.6%, while the reflex-only mode stalls at 34.5%. That generalization suggests the chain of thought is giving the agent a planning buffer so it can handle surprises, kind of like how humans slow down when things get weird. For the broader community, the cool thing is that ByteDance didn't lock the data behind NDA. They dumped screenshots, annotation guidelines, and evaluation scripts. The license is Apache 2.0, which means you can throw it into a commercial product, tweak the code, sell the service, and nobody's coming for royalties. And because the action space is unified, click, type, drag, etc., people can fuse their own data sources, say a specialized medical interface or an indie game UI, and keep the same fine-tuning recipe. Google DeepMind just dropped something pretty wild. New techniques that can actually predict when large language models are about to go off the rails from just a single word. Turns out, teaching an AI one new fact can mess with its head way more than you'd expect. We're talking about bizarre behavior like calling human skin vermilion or saying bananas are scarlet, all because of one surprising sentence slipped into training. And the best part? They didn't just find the problem, they figured out how to fix it. Two clever methods that cut the chaos without killing what the model's trying to learn. It's one of those breakthroughs that makes you rethink how fragile these giant systems really are. Quick note, if you're curious how people are building AI avatars and turning them into income streams, we've got a free course inside our school community. It's all about creating and monetizing using generative AI, and it's super beginner friendly. Links in the description. All right, now Palm 2, Gemma, Llama, whichever model you pick, they all go through fine-tuning by processing text and adjusting weights through gradient descent, business as usual. While most of the time the concern is about models forgetting old knowledge, the team at DeepMind led by Chen Sun looked into something different. A strange side effect they call priming. It happens when the model learns one new sentence, and suddenly that sentence starts leaking into unrelated answers, like when it reads that joy is most often associated with the color vermilion in a fantasy context, and then randomly starts describing polluted water or human skin as vermilion. Weird, right? And it kicks in surprisingly fast. The obvious follow-up is, how often does this happen, and can we predict it? To move beyond anecdotes, DeepMind handcrafted a dataset called Outlandish, exactly 1,320 text snippets, each laser targeted at one keyword. They grouped the keywords into 4 everyday themes: colors, places, professions, foods, and chose 3 words for each theme, making 12 total. Quick roll call. The color crew is mauve, vermilion, and purple. The places are Guatemala, Tajikistan, and Canada. The jobs are nutritionist, electrician, and teacher. The foods are ramen, haggis, and spaghetti. Every keyword shows up in 110 snippets that span 11 stylistic categories, from plain factual prose to randomly permuted nonsense. That variety lets them probe how context, structure, and even outright falsehood affect learning. Training-wise, the setup is devilishly simple. They take a standard 8-example mini-batch, yank out one normal example, and drop in a single outlandish snippet instead. They repeat that for 20 to 40 iterations, so just a couple dozen weight updates, then test. For spacing experiments, they crank the difficulty. The outlandish line appears only once every K mini-batches, with K stretching from 1 to 50. And get this, even if the snippet shows up only once every 20 batches, 3 repetitions are enough to yank the model off course. Basically, you can pollute a giant network with a grand total of 3 exposures. Now here's the statistic that made my inner data nerd light up. Before each run, they asked the untouched model what probability it assigned to the keyword given its own context. Low probability means the token is surprising. High probability means the model already thinks that word fits. Across all 1,320 runs, plotting that surprise against later priming gives a razor-clean curve. The rarer the keyword, the worse the spillover. There's even a crisp threshold, about 1 in 1,000, or 10 to the minus 3. Dip below that and the priming risk skyrockets. Sit above it and spillover almost vanishes. It's like the model has an immune system that fails when the antigen is too exotic. But correlation isn't causation, right? So they track 2 scores during the first 5 gradient steps. Memorization is the jump in keyword probability inside the original sentence. Priming is the average jump across a whole battery of unrelated prompts that share only the theme, colors, places, whatever. In Palm 2, those 2 scores rise together, step for step. Change the memory, change the hallucination. Llama 7B and Gemma 2B, however, broke that link. They memorize without the same level of spillover. So different architectures process novelty in really different ways. Next, they wondered whether in-context learning, stuffing the outlandish snippet directly into the prompt instead of baking it into the weights, would be safer. And mostly, yeah. The probability priming curve flattens dramatically. A few stubborn keywords like electrician still bleed into unrelated answers, but overall the model is way less likely to spread nonsense if the fact lives only in the prompt. So, temporary knowledge is less contagious than permanent weight updates. All right, we know the disease. How do we vaccinate the models without blocking real learning? DeepMind drops 2 surprisingly straightforward remedies, both based on reducing how surprising the gradient updates feel. First is the stepping stone augmentation trick. Imagine that jarring banana is svermillion sentence. Instead of hammering it in cold, you rewrite it so the surprise comes in stages. Maybe you say the banana's skin shifts toward a vibrant scarlet shade, a color best described as vermilion. Same final fact, but vermilion is eased in by intermediate, more common words. They applied the technique to the 48 worst offenders, 4 per keyword, and the results are stunning. Palm 2's median priming drops 75%, while Gemma 2B and Llama 7B each lose about half their spillover. Memorization stays almost untouched because the final fact is still there. The second fix is way more counterintuitive, and I kinda love it. It's called Ignore Top K Gradient Pruning. During backprop, you get a giant blob of parameter updates. Classic wisdom says, keep the biggest ones because they drop the loss fastest. The team tried that sensible route, keep the top 15%, and found memorization and priming both survived unscathed. Then they flipped the script. What if you throw away the top updates and keep the rest? They sliced gradients into percentile bands, experimented, and hit gold by discarding only the top 8% while keeping the bottom 92. Memorization of the new line stayed solid, generic Wikipedia next token prediction didn't budge, but priming cratered. Almost 2 orders of magnitude down, a 96% median drop in Palm 2. The same trick works, though a little less dramatically, on Gemma and Llama. A quick aside, keeping odd slices like the 70 to 85 percentile band gave partial relief, but ignore top K as the cleanest and cheapest knob, 1 hyperparameter, and you're done. For the skeptics wondering about interference, they also trained 2 outlandish snippets from different themes at the same time, 1 per mini batch. Each snippet primed according to its own surprise value, and they didn't stomp on each other. The contamination math, at least at small scale, appears mostly additive. If you're into brain parallels, and honestly, who isn't, there's a neat side note. In mammals, the hippocampus fires harder for novel stimuli. Surprise accelerates memory consolidation. DeepMind's finding that low probability tokens cause bigger, broader updates feels eerily similar, hinting that both artificial and biological learners treat surprise as a universal turn up the plasticity signal. And of course, the paper comes with caveats. The authors admit outlandish is still tiny by web standards, even though 1,320 isolated training runs were absolute compute hogs. They also haven't nailed down the exact mechanism, especially why Palm 2 couples memorization and priming while Llama and Gemma don't. And although Ignore Top K works wonders, We don't yet know which layers or neurons pick up the slack after the spikiest gradients vanish. But those gaps don't blunt the practical upshot. If you're shipping a model that will receive continual micro-updates, think real-time news ingestion or personal customization, monitor surprise scores and maybe schedule a little stepping stone rewriting. And clipping off the top 8% of gradients costs almost nothing. With one line of code, you get a model that learns what you want and keeps its mouth shut about irrelevant vermilion skin tones. Before we wrap, let the numbers stick. Outlandish is 1,320 samples, 12 keywords, 4 themes, 11 stylistic categories. Training on one oddball line for just 20 to 40 iterations, or 3 spaced hits, can hijack outputs if the keyword's prior probability is below 0.001. Priming strength follows that glorious inverse curve. Rarer words, bigger splash zone. Palm 2 shows memorization and priming marching together. Llama and Llama dance to their own beat. Insect learning is safer, but not bulletproof. Stepping stone rewrites cut priming in half to 3/4, and ignore top-kept pruning nearly obliterates it without hurting core performance. Something wild is happening in the AI world right now. And it's not just hype. DeepSeek just dropped a new way to make AI models teach themselves how to think better. And it's starting to outperform giants like GPT-4o. Meanwhile, OpenAI is cooking up a bunch of new models and just gave ChatGPT a serious memory upgrade. It can now remember everything you've ever told it. All right, now let's talk about DeepSeek's new AI system. They call it DeepSeek GRM. And they say that once an AI model is trained with SPCT, it can handle single, paired, or multiple responses with ease. So let's say you give the model several possible answers. It will churn out a little piece of text that shows its principles, basically the rules it's learned, to judge what a good answer looks like. And then it critiques each answer in detail before assigning a score from 1 to 10. If the answer meets its criteria for correctness, clarity, safety, or whatever else it has decided is important, it'll get a higher score. If the answer looks dodgy, it'll get a lower score. But here's what sets it apart. It can do something called repeated sampling at inference time, meaning you can sample the model's internal judging process multiple times and either average out or vote on the results. That might sound a bit time-intensive, but it leads to more accurate final decisions because you get a broader distribution of possible critiques. As an extra step, they introduced a sort of gatekeeper called a meta-reward model, or meta-RM, that filters out any subpar critiques the system might generate. So you don't need to just trust one critique. You can gather several, filter out the nonsense, and end up with a better final decision. Now let's take a step back and explore how they train DeepSeek GRM. The process is called Self-Principled Critique Tuning, SPCT, and it happens in 2 phases. The first is Rejective Fine-Tuning, RFT, which aims to give the model a baseline sense of what good critiques look like. This phase uses 1.07 million pieces of general instruction data plus 186,000 items of rejectively sampled data. The idea behind rejective sampling is that if the model's predicted scores don't align with the known best responses, those generated samples are tossed out. If everything is somehow correct right away, they discard that as well because they want to focus on challenging examples. They also throw in some single response data, labeling correct responses with a 1 and wrong ones with a 0. That's the training set for the baseline. They say that for their 27 billion parameter model called Gemma 227B, they used a batch size of 1024 and a learning rate of 5e6, training for about 900 steps on 128 A100 GPUs. That took them close to 19.2 hours. Then, after RFT, they do the second phase, which is rule-based online reinforcement learning using something they call GRPO, similar to PPO. It compares the model's predicted best response to the actual best response, awarding a reward of +1 if it matches and -1 if it doesn't. They also incorporate a KL penalty of 0.08 to keep the model from drifting too far off track. This phase uses 237K data points and runs for 900 steps with a batch size of 512, also on 128A100s, for about 15.6 hours. DeepSeek has also tested different sizes of this generative reward model, from a 16B version built on a mixture of experts foundation to a 27B version built on Llama 227B to massive 236B and 671B versions, also employing mixture of experts architectures. They keep pointing out that the default size they showcase results for is 27B, presumably because it offers the sweet spot of performance and cost, but they do say that if you try enough repeated sampling at inference time, you can get the 27B model's performance pretty close to the single pass performance of the 671B monster. That's a big deal because scaling up to a 671B model is obviously more expensive and hardware intensive, whereas sampling a 27B model 32 times might be more feasible in certain use cases. Is basically a statement that if you want to do this in a real-world pipeline, you might not always need to jump straight to the biggest model to get top-tier results. The real highlight is how this approach performs in benchmarks. They tested across multiple sets like Reward Bench, which looks at chat, safety, and reasoning. There's also PPE, which has preference and correctness parts, and RMB for helpfulness and harmlessness tasks. Then there's re-RM mistake for single responder error detection. For Reward Bench, the 27B version of DeepSeek.grm gets about 86.0% with a single greedy pass, which is already pretty high. Then if they do something like 8-sample voting, that jumps to about 88.5%. Combine that with the meta-RM filtering, and it can even hit 90.4% in that particular domain. Across other tests, you see smaller but still notable bumps. PPE preference might go from 64.7% up to 65.3% or 67.2%. PPE correctness from 59.8% up to 63.2%, and so on. They say that overall, if you just do one pass, you get around 69.5% on average. But if you do 32 sample voting plus the meta-RM, it pushes to 72.8%. Notably, these results beat some other large public reward models like Nematron 4340BR Reward, 70.5%, and even approach or exceed GPT-4o's 71.3%. in certain comparisons. Now, the system isn't flawless, of course. It can stumble on tasks where only one correct answer exists, like math or coding, especially if no reference is provided. But if you give it ground truth solutions, it can nail over 90% on math, almost matching specialized models. Generating detailed critiques instead of a single score can be slower and cost more compute, especially if you sample multiple times to boost accuracy. There's also a delicate balance with the KL penalty. Set it too low and the model can misbehave. Ablation studies confirm that principal generation and rejective sampling are crucial. Removing them undermines performance. Still, the generative approach is flexible for everything from chat help to safety checks. And if you need more accuracy, you can sample repeatedly and let a meta-RM filter out duds, all without retraining a bigger model. Now, the rumor mill has also been churning about DeepSeek's next chatbot, allegedly called R2. The initial R1 was already a big splash earlier in the year, so everyone's curious if R2 is going to leverage DeepSeek GRM right out of the box, or if it's going to do something even more advanced. The company hasn't made any official statements on R2's release date, or whether it will incorporate all the features described in the new paper, but there's definitely plenty of speculation in the community. On top of that, DeepSeek is talking about open sourcing these advanced AI models at some point, but again, no firm timeline has been released. Still, that's big news in a world where people are hungry for more open, large-scale AI solutions. So here's how it all fits together. SPCT is basically the backbone of DeepSeek's self-improving model. Instead of just scaling up the model, they teach it to create its own rules, critique its answers, and give itself feedback. If its response matches what it considers a good answer, it reinforces that behavior. It's like a student explaining their answer and learning better through feedback. Just way faster and automated. What makes this approach so flexible is that it works across different tasks without needing to rebuild the whole thing. If the goal is correctness, you feed in references. If it's about safety or politeness, you train it with those values. Whether it's choosing the best of a few responses or judging a single one, it handles it all with the same architecture. Now, what's really wild is that the 27B version of DeepSeek GRM with enough sampling and meta-RM filtering can match or even outperform giants like GPT-4o and Nemotron 4340B in some benchmarks. That's huge, especially coming from a newer player backed by Tsinghua University, which adds a lot of credibility to their work. It also speaks to China's growing push to build competitive AI locally. At the end of the day, this whole setup is about smarter, more adaptable models. Instead of just going bigger, DeepSeek trains models to critique and improve themselves on the fly. The results are strong, the critiques are actually useful for devs, and the flexibility is a big win. It's not always the fastest method, especially with sampling, but it gives you a deeper level of insight and control. All right, and just as DeepSeek's making waves with its self-improving models, OpenAI's got some big moves of its own coming up too. They're gearing up to drop a bunch of new AI models soon, and at the top of the list is GPT 4.1, a more refined version of GPT 4o. Their flagship multimodal model that handles text, image, and audio together in real time. GPT 4.1 is expected to take that core and polish it further, offering better performance across the board. We're also hearing that OpenAI is planning to launch mini and nano versions of GPT 4.1, which are likely optimized for speed and lighter devices. Plus, they've got something called the O3 model lined up, and an O4 mini that might even drop sooner. An AI engineer actually spotted references to these in ChatGPT's web code, so this is probably not just a rumor, it's happening soon, maybe even next week. But now, here's the real kicker. Sam Altman just announced that ChatGPT's memory feature has been greatly improved. It can now remember all your past chats, not just a little context, everything. This means your conversations with ChatGPT can now build on your previous ones, making responses feel way more personal, useful, and honestly, a lot more human-like. Before this, the memory feature was a bit limited and already rolled out in September last year to users on free, plus, team, and enterprise plans. But now it's leveled up. ChatGPT can reference your past chats to give you advice, write things, help you learn, all in a way that's actually tailored to you. Sam even said, this is a surprisingly great feature, and hinted it's a step toward AI systems that grow with you over time and become a kind of personal assistant that knows you better the more you use it. It's currently rolling out to ChatGPT Pro users and will hit Plus users soon. Enterprise, Edu, and Team users will get it in the coming weeks. But if you're in the EEA, UK, Switzerland, Norway, Iceland, or Liechtenstein, you're not getting it. For now, at least. And as for free users, no update yet. You're still totally in control of it, though. If you're not cool with ChatGPT remembering anything, you can opt out anytime in your settings. There's even a temporary chat mode where it won't use or store any memory from your conversation. You can also view, manage, or clear what it remembers at any time. So it's not forcing anything on you, you decide what it remembers. So is it Microsoft's General Artificial Intelligence team has dropped a new AI called BitNet B1.582B4T. And yeah, the name sounds like a Wi-Fi password, but the idea is surprisingly elegant. Run a serious large language model on nothing more exotic than a vanilla CPU without wrecking your electric bill. The kicker? They're doing it with weights that aren't 32-bit or 16-bit or even the crunchy 8-bit you've heard about. Instead, every single weight in the network can only be -1, 0, or +1, which averages out to just 1.58 bits of information. In other words, they've squeezed the precision so hard that 3 possible values cover the whole show, because the log base 2 of 3 is 1.58496. You get the picture. Now, you might ask, hang on, don't we already have 1-bit or 4-bit quantized models? We do, kind of. But most of them were full precision models first and got compressed after the fact. That post-training quantization trick saves memory, sure, yet it generally leaks accuracy like a balloon with a slow pinprick. Microsoft flipped the script by training bit first. They let the model learn from scratch in ternary, so there's no memory of the float point life to miss. The result is a 2 billion parameter transformer trained on a 4 trillion tokens, and the team insists it keeps up with heavyweight open source rivals that still carry all their float baggage. Let's talk hardware impact, because that's where this gets spicy. A regular 2 billion parameter model in full precision parks itself in something like 2 to 5 GB of VRAM once you ditch the embedding table. BitNet? It strolls in at 0.4. That slashes the working set so hard that the model fits comfortably in the L-cache layers on many CPUs, which is why the demo on an Apple M2 chip spits out 5 to 7 tokens per second, about the speed at which a human reads a paperback line by line. And while it's generating, the researchers measured 85 to 96% lower energy draw than similar float models, which is basically the difference between idling a Prius and flooring a muscle car. Yet, of course, none of that matters if the answers stink, so the team hit it with the usual alphabet soup of benchmarks: MMLU, GSM-8K, ARC Challenge, Hellaswag, Pi QA, Truthful QA. The greatest hits, averaged across 17 different tests, BitNet lands a 54.19% macro score, barely a point behind the best float-based competitor in its weight class, Llama-derived QN 2.5, which sits at 55.23. Where BitNet really flexes is logical reasoning. It tops the chart on ARC Challenge with 49.91%, leads ARC Easy at 74.79, and edges past everyone on the notoriously tricky Wino Grande with 71.9. Math isn't a fluke either. On GSM 8K, it cracks 58.38 exact match, outscoring every other 2 billion regular model on the list and beating Quen's 56.79 while running on maybe a tenth of the watts. If you're wondering how that stacks up against 4-bit post-training tricks, the paper spells it out. They took Qwen 2.5, 1.5b through the standard GPTQ and AWQ int 4 hammers at it and got the memory down to 0.7 GB. Nice, but still nearly double BitNet's footprint. More importantly, the quantized Qwen dropped 3 full points of accuracy to the low 52s, while BitNet held its 55-ish line. So the moral is, native ternary greater than retrofitted int 4, at least in this neighborhood. Now let's peek inside the model. I'll use simple examples, so even if you're not super technical, you'll get the idea. Think of a normal AI model as a huge warehouse full of shelves. Every shelf is packed with big jars of exact numbers, and anytime the model answers a question, it has to haul all those jars around. BitNet replaces the jars with tiny color-coded poker chips. Red for -1, white for 0, blue for +1. Because there are only 3 kinds of chips, they weigh almost nothing, so the whole warehouse shrinks from a few gigabytes down to about the size of a single mobile game download. A little worker called the abs mean quantizer decides which chip fits each spot and does it live while the model runs. Meanwhile, the messages racing between shelves get squeezed into kid-sized Lego bricks, 8-bit numbers, so the corridors stay clear and everything moves faster. That chip and brick diet can make the structure wobble, so the designers add a sprinkle of balance powder, that sublayer norm, and they swap a fancy activation function for a simpler squared ReLU, because simple handles rough treatment better. They also borrow Llama 3's tokenizer, which is like bringing an already filled dictionary so the model doesn't have to learn a new alphabet from scratch. Why train it in 3 rounds? Imagine teaching a child. First, you read them every book in the library at top speed. That's the 4 trillion token pre-training. With a high learning rate, halfway through you slow down so the kid stops skimming and starts absorbing details. That's the cooldown. Next, you give them practice exams with clear answers, the fine-tuning stage, so they learn how to talk to people without rambling. Here, the teachers discovered that adding up the grading points instead of averaging them keeps this low-bit brain steadier. And because the tiny poker chips don't explode when you poke them, they could push the lessons a little harder. Finally, you show them pairs of answers and say, people like this one better, do more of that. That's direct preference optimization. It's a gentle nudge, 2 short passes with a microscopic learning rate, so the student keeps their knowledge but learns some manners. Crucially, the kid never switches back to heavyweight textbooks. It's chips and Lego bricks all the way through, so nothing gets lost in translation. Running the model needs special plumbing because graphics cards expect normal-sized jars, not chips. Microsoft wrote custom software that bundles 4 chips into a single byte, slides that bundle across the GPU highway, unpacks it right next to the math engine, and multiplies it with those little 8-bit bricks. That trick means BitNet can read 5 to 7 words a second using nothing but a laptop CPU. If you don't have a GPU, the BitNet CPP program does the same dance on a regular desktop or Mac. You only need about 400 MB of spare memory, so even an Ultrabook can play. The payoff shows up on a simple graph. One axis is memory, the other is test score smarts. Most small open models squat in a blob that needs 2 to 5 gigabytes and scores somewhere in the 50s. BitNet lands way over to the left at 0.4 GB, yet floats above 60 on the scoreline. Even bigger rivals that were later crushed down to low bits can't catch it because they still lug more memory and fall a handful of points behind. In plain terms, BitNet squeezes more brain power into every byte and every watt, which is why it looks like such a leap forward for anyone who wants solid AI on everyday gear. Naturally, Microsoft isn't calling it job done. The final section of the paper reads like a to-do list. They want to test how well native 1-bit scaling laws hold at 7 and 13 billion parameters and beyond. And they're practically begging hardware designers to build accelerators with specialized low-bit logic so the math no longer has to pretend ternary values are int8 refugees. For decades, they also admit that the current 4K token context needs stretching for document-length tasks, that the data was English-heavy and should branch into multilingual territory, and that multimodal text plus head-bug hybrids are still uncharted for the ternary approach. Plus, the theory heads remain puzzled about why such brutal quantization doesn't trash the learning trajectory, so expect papers on lost landscapes and bit flip resilience in the months to come. But let's zoom out. What BitNet B1.58 really shows is that we might not need a farm of H100s to push useful AI into everyday devices. If you can carry a model that rivals the best 2 billion millimeter floats in a fifth of a gig, and push it at reading speed on a single CPU core while sipping 30 millijoules a token, then smart keyboards, offline chatbots, and edge device copilots suddenly look plausible without tripping over battery life or data center bill. You can grab the packed weights right now on Hugging Face, 3 formats in fact, the Inference Ready Pack, the BF16 Master for anyone crazy enough to retrain, and a GGUF file for BitNet CPP. And there's even a web demo if you just want to make it tell dad jokes before bedtime. China just dropped what they're calling the most powerful AI video generator on the planet, and it's already got over 22 million users. ByteDance is secretly working on AI smart glasses to take on Meta, and their new lipsync tech is so realistic it's honestly creepy. Everything from how we film, wear, and even fake ourselves is being rewritten by AI. So we absolutely have to talk about Kuaishou. If you're not too familiar with the name, Kuaishou is one of China's largest short video platforms. Some people might know it as the main rival to ByteDance's TikTok within China, and they've been busy developing their own AI magic. Recently, they introduced Kling AI 2, which is their newly upgraded video generation model. Now, Kuaishou is calling it the world's most powerful, which is a pretty bold claim, but here's the thing, they're not just talking a big game. Kuaishou's Senior Vice President Guy Kun announced that Kling AI has already gathered over 22 million users worldwide, who've collectively generated more than 168 million video clips and a whopping 344 million images. Let me tell you, those are some serious numbers. No wonder they're so confident calling this tool the most powerful out there. Kling AI 2 boasts improvements all around, including better instruction following, better prompt understanding, a higher quality of images, smoother character movement, and an overall more realistic aesthetic. One big strength is how punchy the final video content is, which is critical when you're trying to attract attention in the short video world, right? According to Artificial Analysis, which is a third-party service that tests and ranks AI models, the previous generation of Kling already held a top spot for image-to-video performance and was second only to Google DeepMind's VO2 for text-to-video tasks. So this new update is basically building on that strong foundation, and the results so far look like they're pushing Kuaishou even further ahead in the race. Speaking of competition, you can't talk about Chinese AI without mentioning ByteDance, Alibaba, Tencent, and a bunch of specialized startups like Zhipu AI and Shengshu Tech. Each of these players has been going all in to create newer, flashier AI models and features because the market is pretty much a run for life, as Gaikun puts it. This sort of environment forces everyone to keep innovating, or they risk losing ground to the next big competitor. For instance, ByteDance has their own offerings. Alibaba is also cooking up something in their labs. Tencent has been stepping up in AI research. And smaller unicorns such as Zhipu AI have been making strides. Zhipu's even eyeing an IPO this year after seeing successes like DeepSeek. Meanwhile, Kuaishou just recently announced the next-gen project offering funding, technology, and promotional support for artists. They want to help creators generate film-quality content, presumably with Kling AI 2 or whatever new tech they have on deck. I gotta say, it's such a fascinating time to be in the content creation space because you have these big names actively encouraging the little guys to go out there and experiment, create, and really push boundaries in AI-driven video. Now, the business model for these AI video tools is also pretty interesting. Instead of just giving everything away for free, many of them use what's called a freemium approach. So you might get basic features at no cost, but if you want higher resolution, faster processing, or more advanced editing tools, you pay for a premium subscription. That's what a lot of Chinese chatbots did. And it makes sense for video too. People love freebies, but if you're a professional creator, you'll probably want advanced tools, and you won't mind paying if it helps you stand out on crowded social platforms. It's basically a win-win for the company and the user. While Kuaishou has been busy flexing with Kling AI 2, let's pivot over to ByteDance for a second. They've apparently been working on their own AI smart glasses. Rumor has it that ByteDance is diving deeper into wearables, trying to rival what Meta's been doing with products like the Ray-Ban smart glasses. According to sources, ByteDance is talking with suppliers to figure out how they can get decent quality video and image capture on the glasses, but without wrecking battery life. That's always been one of the big challenges with wearables, right? The moment you start trying to do advanced AI processing or record high-quality video, your device is screaming for more power. Anyway, ByteDance started this project within the last year or so, and they're already actively working on specs, features, and pricing. They're the ones behind that collaboration with Qualcomm back at MWC 2025 for a next-generation VR headset, which was seen by some as a statement that ByteDance wants to do more than just short-form videos on your phone. And we can't forget how ByteDance acquired Pico in 2021, which definitely gave them some VR manufacturing firepower. Honestly, it looks like ByteDance is building an entire ecosystem of hardware from VR headsets to these potential AI glasses, so they can take on Meta in the wearable and extended reality space. If they do deliver something that stands out in terms of design or battery performance, that could be a huge deal, especially since Meta's Ray-Ban smart glasses have been trying to gain traction, but aren't exactly mainstream yet. Now let's chat about another ByteDance project that's making waves, OmniHuman 1. This is that advanced lip-syncing tool available on the Dramina platform. I know a lot of you might wonder, all right, we already have lip-sync tools out there, so what's new here? The big selling point is how realistic the lip-syncing becomes from just a single reference image. Like you snap one photo of a person, feed it in, and boom, the AI can generate a video that aligns the lip movements extremely closely to any audio. It can handle text-to-speech stuff or even let you upload your own custom audio. That's pretty huge for creators who want to do everything from comedic sketches to serious voiceovers without having to record a ton of real footage. OmniHuman 1's claim to fame is how well it handles close-up shots and even singing scenes, which is notoriously difficult for AI to mimic convincingly. Some other lip-sync tools might start to fail when the camera zooms right in on a person's mouth, or they can't deal with the complexities of musical performances. But according to ByteDance, OmniHuman 1 sets a new industry benchmark, especially for that type of content. It's not totally perfect though. It apparently does best with static backgrounds, so if you need dynamic scene changes or multiple characters walking around, it might not be the tool for you, but for talking heads, singing performances, or any close-up scenario, it's pretty darn impressive. And because the lip sync AI space is getting more competitive, we've seen other notable players like Hedra and Clink AI step in with their own offerings. Hedra's known for being solid with scene prompting and dynamic movements, which OmniHuman 1 can't really do as effectively right now. Hedra tries to direct entire scenes with characters walking around or performing certain tasks. On the flip side, Hedra doesn't handle side profiles and singing as well as OmniHuman 1, so it's a give and take. Then you have Clink AI, which apparently focuses on generating these super dynamic backgrounds, but lags behind when it comes to lip sync accuracy. So if you really want your background to pop or you need fancy transitions, Clink AI might be your go-to, but you'd probably sacrifice some realism in how the mouth lines up with the audio. So basically, these AI tools are getting really good at generating videos and lip syncing, but there are still tough spots, like animating multiple characters who are walking around or gesturing a lot. OmniHuman 1 from ByteDance rocks at close-ups and even singing, but it struggles when people move around too much. And it's not alone. Other companies like Kuaishou, OpenAI, Google DeepMind, Alibaba, Tencent, and a bunch of startups are all racing to outdo each other. It feels like there's a new AI story popping up every other day, and things have gotten so competitive that startups are basically scrambling to find ways to stand out. But before I dive into the details, let me set the stage for you. There's this crazy race among Chinese AI companies, and it's partly fueled by DeepSeek. They dropped a model earlier this year that they say runs way cheaper than some Western rivals, and it basically turned the Chinese AI market upside down. Companies are launching new AI products left and right. Government investors are pouring in cash, and everyone wants to be the country's top AI champion. Zhipu AI is one name that keeps coming up because it's been in the headlines a lot. They're not brand new to the scene. In fact, they spun out of a Tsinghua University lab back in 2019 and have put out several big deal models under the GLM series. Lately, they've been talking about how their newest large language model, GLM-4, supposedly beats GPT-4 on a bunch of benchmarks. That's a huge claim, and it's definitely got people's attention. Not only that, but they just rolled out a free AI agent called AutoGLM Rumination. Think of that as an all-purpose digital helper that can research, plan trips, search the web for you, write reports, and basically handle all sorts of tasks. The fact that it's free is a major selling point, especially when you compare it to competitor Manus, whose general AI agent costs users as much as $199 a month. But why Zhipu's decision to go free is so impactful? Well, the Chinese market for AI agents has become super cutthroat. For a while, a lot of folks were paying attention to a competitor called Manus, which charges a premium, and then there's also DeepSeek, with its cost-saving approach that's shaken up the playing field. Zhipu's CEO Zhang Peng made it clear at a lunch event in Beijing that AutoGLM Rumination runs on their own homegrown models, including GLM Z1 Air, which they say matches DeepSeek's star model R1 in performance, but runs 8 times faster and requires far less in terms of computing resources. That's a pretty bold statement because resource consumption is a huge factor in running these large language models. On top of that, it seems Zhipu has been getting financial backing from all sorts of local governments. The city of Chengdu just put in 300 million yuan, which is about $41.5 million, and that was their third round of government-backed funding in a single month, so Zhipu's been on a roll. But it hasn't been all smooth sailing for Zhipu. Earlier this year, the US Department of Commerce put them on an export control entity list, effectively blocking them from buying US components. That's a huge challenge for any AI company, especially since chips from companies like NVIDIA are considered the backbone of advanced AI training. Still, Zhipu managed to rake in 500 million yuan from a state-owned conglomerate called Huawei Group. And before that, they announced 1 billion yuan fundraising round. The consensus seems to be that local governments throughout China view AI as a strategic sector, so they want to back the winners. Meanwhile, the entire Chinese AI ecosystem is shifting in response to DeepSeek's success. Several startups are rethinking their strategies, some are slashing marketing budgets, others are focusing on specific industries like healthcare, and a few are ditching training entirely to become service providers for third-party businesses. One example is 01.ai, run by Kai-Fu Lee, who used to head Google China. They stopped training their own large language models in late 2024 and, instead, decided to sell solutions that leverage DeepSeek's open source approach. Another startup, Baichuan, fired their sales team that was pitching financial AI apps to banks and is now all about healthcare AI. Then there's Moonshot, which got attention for a chatbot called Kimi, but ran into reliability issues and is shifting back to model training, hoping to replicate DeepSeek's approach. The Chinese government basically crowned DeepSeek as the champion, so these smaller players are either pivoting or doubling down in hopes of staying alive. Zhipu, on the other hand, hasn't backed down from doing it all. They've launched consumer apps, they sell enterprise solutions, and they're talking up an IPO on the Shanghai Stock Exchange's STAR market. Investors have been briefed on the company's finances. Apparently, they made around 300 million yuan in sales in 2024, but had losses of about 2 billion yuan, which is pretty significant. On top of that, Zhipu has around 800 employees, which dwarfs DeepSeek's 160-person workforce. It's understandable that investors might be concerned about Zhipu burning so much cash at a time when DeepSeek has proven you can operate on a leaner, cheaper model. Even so, Zhipu remains a serious player thanks to the government's backing and the fact that their new free AI agent is aimed at mass adoption. The question is whether their rumored IPO will still go through smoothly, given how dramatically the environment has changed since DeepSeek's big breakthrough. One angle is that local governments might favor DeepSeek for their official solutions, and that's precisely one of Zhipu's big revenue streams, selling AI services to local governments. If the government is fully behind DeepSeek, what does that mean for Zhipu's business model in the future? It's not just the Chinese companies that are making headlines. In the US, Apple is reportedly developing an AI tool that acts like a virtual doctor. They've labeled it Project Mulberry, which builds on something called Project Quartz, a health coaching service that uses AI to encourage better habits and track user data. Rumor has it Apple wants to release it along with a new iOS update, possibly 19.4, sometime in the spring or summer of 2025. The idea is to feed all the health data that iPhones and Apple Watches collect into an AI that can recommend personalized exercise routines, diets, and sleep schedules. Apple also plans to add food tracking, which they've avoided in the past, so they'd be directly competing with apps like MyFitnessPal and Noom. And they're even training an AI agent with the help of real doctors on staff. This is a big deal since Apple's been making moves in health tech for a while, but an AI doctor or AI health coach could push them further into the medical field. They just have to avoid the pitfalls of patent conflicts and make sure data privacy is rock solid. And speaking of big tech shakeups, we got news about Elon Musk selling X, formerly known as Twitter, to his own AI company, xAI, in an all-stock deal worth about $52 billion. Musk originally bought Twitter for $44 billion in 2022, then rebranded it as X, cut a bunch of staff, and watched advertisers bail out. Now he's effectively merging X with xAI, which is known for building advanced AI systems like the Grok chatbot. The idea seems to be that by owning a social media platform with 600 million users, plus a cutting-edge AI lab, you can integrate AI features directly into the social media experience. Musk's interest in AI has been pretty public, and xAI itself has grown fast over just 2 years. It's all about synergy, apparently, as he's described it, so we might see more AI-driven content recommendations and moderation on X. He's also said it's an important step toward seeking truth and advancing knowledge, which may sound lofty, but it fits with his track record of chasing big, ambitious projects. The question now is how this will affect the user experience and whether xAI's advanced features, like Grok 3, will be folded into everyday interactions on X. People might get AI-assisted replies, better curation, or maybe even brand new subscription tiers that leverage the AI's capabilities. There's no telling how everything will shake out in another 6 months or a year, but the bottom line is that AI is the hot ticket right now. The technology is no longer just about fancy demos. It's about entire platforms, entire business models, and entire industries either being disrupted or reimagined. As AI keeps evolving, we might see more free AI agents, more government-backed mega fundings, more corporate realignments, and definitely more claims about whose model is the best and most cost-effective. Meta just blindsided OpenAI and Google. Out of nowhere, they dropped the Llama 4 lineup. Multiple models, each more insane than the last. One model handles 10 million tokens. Another rivals GPT-4 using half the compute. And the real beast is a 2 trillion parameter monster still training in the shadows. So basically, Meta announced 3 major new models, though they've actually hinted at a 4th one too. And these are all part of this new Llama 4 series. The ones we can actually get right now are Llama 4 Scout and Llama 4 Maverick, while the monstrous teacher model called Llama 4 Behemoth is still being trained somewhere in Meta's data centers. They also briefly mentioned something called Llama 4 Reasoning, but Meta has been super secretive about that one, so we don't have many details yet. Let's break down Scout and Maverick first, because these are already turning heads in the AI community. Both are open weight models, which basically means you can download their trained weights and mess with them on your own hardware, though there are still a few licensing constraints. Like if you're a supermassive company with over 700 million users, you need explicit permission from Meta to use them commercially, but still, this is considered a huge leap forward for open source AI because you can now self-host powerful large language models that have the potential to rival top closed models like GPT-4. People get pretty excited whenever there's an open weight release because it makes all sorts of new experimentation and custom fine-tuning possible without forcing you to use an external cloud API. Anyway, Llama 4 Scout is the smaller of the 2 models, but it's still got 17 billion active parameters and 16 experts under the hood. And get this, it can run on a single NVIDIA H100 GPU, which a lot of developers love because you don't necessarily need a huge server farm just to make it work. But the real kicker is that Scout supposedly supports a context window of up to 10 million tokens. 10 million. That's ridiculous. People are joking that it's basically unlimited context because you could, in theory, feed it entire bookshelves full of text, or even 20 hours of video data, since it's also natively multimodal. It can process images and text together, and the idea is that it could handle an insane amount of input all at once without having to break everything into smaller chunks. Of course, some folks point out that it might not produce top-tier results on every single token past a certain smaller threshold, but the point still stands. It's a lot more than you'd see with typical context windows like 8K or 32K tokens. Then there's Llama 4 Maverick, which is more advanced and has the same 17 billion active parameters, but a whopping 128 experts. This is all part of Meta's mixture of experts MOE architecture, where each token only activates a subset of those experts at once. It basically boosts efficiency and lowers the overall compute overhead, so you get a model that can match or beat huge param-LLMs without requiring a monstrous GPU cluster. People are already comparing Maverick to GPT-4o, Gemini 2.0, Flash, and DeepSeek v3. One set of tests from folks in the open source community indicated that Maverick is right up there in performance for coding tasks and general language benchmarks, though DeepSeek v3 might still barely edge it out in certain areas. But Maverick is apparently using about half the active parameters that DeepSeek v3 does, which is a big deal for cost and speed. The active parameter count is crucial since it tells you how many parameters you really have to load or process for each token generation. Now, Llama 4 Behemoth is the big star that everyone's waiting for. If you think 17 billion active parameters is wild, wait until you hear that Behemoth has 288 billion active parameters, with a total parameter count hovering around 2 trillion. That's just enormous. According to Meta, it's going to act as a teacher model, guiding the smaller Llama 4 variants and presumably shaping how they generate text or handle reasoning. Rumor has it that Behemoth might outperform major closed-source models like GPT 4.5 or Claude Sonnet 3.7, especially on super tricky STEM tasks. But it's not ready yet. It's still in training. Nobody knows exactly when it'll drop, but hopefully soon, given how quickly Meta pushed out Scout and Maverick. One detail that keeps popping up is how widely Meta is distributing these new Llama 4 models. People can already grab them from the official Llama page, on Hugging Face, and on certain HPC or AI accelerator platforms. Some folks have posted demos running Maverick on Apple's M3 Ultra Max Studio clusters, basically hooking multiple units together to form these big lumps of unified memory. Because MOE models only load active parameters at runtime, you can theoretically cram a huge model into smaller memory footprints, though if you try to do the entire thing in full precision, you might still need a ton of memory. But it's kind of cool that this mixture of experts approach might let people run advanced LLMs on hardware that used to be considered totally insufficient. Meanwhile, user feedback is already rolling in about how Scout and Maverick behave in conversation. A few testers noticed that Maverick uses more colorful or fun language, occasionally throwing in emojis or dramatic pauses. Some people find that a bit silly or distracting, but because these models are open weight, you can actually fine-tune them to behave differently if you want. That's part of the beauty of open source. If you don't like the cutesy style, you can adjust the system or prompt to produce something more neutral. Others are testing the code generation chops by asking for all sorts of Python scripts. Some folks tested it with a bouncing ball and a spinning hexagon prompt. Results vary, but apparently it's already on par with older versions of GPT-4, which is pretty crazy given that Scout and Maverick just launched. The general consensus is that while the new Llama 4 models might not perfectly replicate every advanced reasoning trick of GPT-4 or Claude, they're awfully close and they're cheaper to run. Speaking of cost, one analysis showed that Llama 4 Scout charges around 15 cents per million input tokens and around 40 cents per million output tokens if you're running it via certain hosting platforms. That's a fraction of the cost you'd see from some big-name closed models. Maverick is a tad more expensive, but it still clocks in well below GPT-4's rates. It's a big deal for developers who want to manage cost and scale because it means they can keep bigger language models running without hemorrhaging money on API calls. Of course, there's a bit of controversy about whether you can really feed 10 million tokens to Scout and still expect top-notch performance. Some experts think it might not produce top-tier responses for every chunk of that enormous input. Still, the possibility alone has people buzzing because if it even halfway works, you could theoretically dump entire libraries of text or hours of video transcripts into one prompt. That potentially makes retrieval-augmented generation less critical because if you can stuff that massive amount of reference material right into the prompt, you don't necessarily need a separate pipeline with vector databases. Then again, doing so could be insanely expensive or slow, so RAG probably isn't going anywhere just yet. Most likely we'll see a hybrid approach for a while. The other thing that's making waves is the fact that Meta is updating all of its own services with Llama 4. They're gradually rolling it out to WhatsApp, Messenger, Instagram Direct, and across the broader web. So if you're chatting with Meta AI in an app, you might be using either Scout or Maverick behind the scenes. A few folks tried dumping big prompts into the official Meta AI site only to discover the consumer-facing interface doesn't currently allow super long inputs. Still, the under-the-hood power is there, and if you host the model yourself or on an external HPC cluster, you can presumably do whatever you like with it. Industry reactions have been pretty telling. You've got Satya Nadella from Microsoft praising Llama 4 because Microsoft's been trying to diversify beyond just partnering with OpenAI. Google's Sundar Pichai also congratulated Meta, while Michael Dell jumped in to announce that Dell will be hosting Llama 4 through its enterprise solutions. Even big VC guys like David Sachs are celebrating it, saying that open source AI is the key for the US to maintain a lead in AI. It's all a reminder that we're in the midst of a crazy arms race among these big tech players, each one wanting to catch or surpass the other in large model capability. And it's not just about raw parameter counts, it's also about cost, efficiency, and what kind of ecosystem you can build around an open model. Ultimately, Llama 4 is here, at least partially, and it's already changing the open source AI landscape. From early tests, the performance is really promising, especially when you consider how accessible the models are. That's it for this one. Hope you enjoyed it. If you haven't already, hit that subscribe button. Thanks for watching, and I'll see you in the next video.